So the meeting's been recorded. I hope now you can see my board. So the topic today is matrices. So matrices. So let us define what is matrix before we introduce other things. So we start with the simple definition for matrix. Now, when we talk about the matrix or matrices, so a matrix refers to a rectangular arrangement of numbers which are enclosed in a bracket. Which are enclosed in a bracket. So the topic is, this one is quantitative. So quantitative analysis. And the topic is matrices. Matrices, and we say define what is matrix. A matrix refers, so a matrix refers to a rectangular arrangement. Rectangular refers to a rectangular arrangement of numbers. Arrangement of numbers which are enclosed within a bracket. Which are enclosed within. Which are enclosed within a bracket. So when we have a rectangular arrangement of numbers which are enclosed or which are within the brackets, we can call it a matrix. We can call it matrix. Okay. So I'm assuming mnanisikia na mnaona kenye inaendelea. So kama naandika lakini msikii sauti, we shall say. Now, okay, those numbers within the bracket are known as elements. Those numbers within the brackets are known as elements. So the numbers which are within the brackets of a matrix, those numbers are referred to as matrix. Then we can also say vertical arrangement of numbers are known, so they're known as matrix. They're known as, no, sorry, not matrix. They're known as column. So when the number are vertically arranged, So those numbers, we call them column. Then horizontal arrangement of numbers are known as rows. They're known as rows. So column usually it is in vertical form, and rows are usually in horizontal. So that is all about matrix definition. So when we talk about matrix, we mean that matrix refers to a rectangular arrangement of numbers which are enclosed within a bracket. Then the numbers within the brackets are called elements. The numbers within the bracket are called elements. Then when the numbers are arranged in a vertical manner, we call them columns. And when the elements are arranged in an horizontal manner, we call them rows. Type of matrix. Type of matrix. So type of matrix. So type of matrix number one. So number one, scalar or single tone matrix. So scalar or the single tone matrix. So make sure you come out to me a simu. Don't auto-rotate your phone. So you use your phone in a normal way. So these are matrix which has only one element. This is a matrix with single element. So a matrix with single element, i.e. This is a matrix, we have A as a single element. So A as single element. We go to number two. Number two, column vector matrix. Column vector matrix. So a column vector matrix is a matrix with one column. It's a matrix with one column. So it's a matrix with only one column, but more than one row. More than one rows, but more than one rows. And we can give example the other side. So example IE. So IE, when we have this kind of a matrix, A, B, and C. So a matrix with one column, and then with more than one rows. Then let's go to row vector matrix. Number three, row vector matrix. And we say it's a matrix with only one row. Matrix with only one row. So matrix with only one row. One row, but more than one column. But more than one column. And you can give example as A, B, and C. So you make sure that your items or your elements inside the matrix, inside the brackets, is not separated with the commas. If you separate them with commas, then they shall not be matrix, they shall be sets. So make sure it doesn't have what we call commas. Number four, we can talk about zero matrix or null matrix, and we can conclude and say it's a matrix with no element. Refers to matrix with no element. Matrix with no element. Sawa sawa. I think hapo iko sawa. So with no element. With no element, then we continue. Number 5, square matrix. Square matrix, and then you can say square matrix is a matrix with equal number of rows and columns. Matrix with equal number of row and column, i.e. A, B, C, D, or 3 by 3, A, B, C, D, E, F, G, H, I. So that's an example. So that's a good example. So 3 by 3 or 2 by 2 matrix. So this one is 2 by 2 matrix. This one is 3 by 3. 3 by 3 matrix. So when you have such kind of matrix, you call them equal, or 4 by 4 matrix also. Number 6. Number 6, we can talk about identity matrix. Identity matrix. And you can say it's a matrix whose major diagonal element are 1. It's a matrix whose major diagonal equals to 1. Is a matrix whose diagonal nimepotea, whose major diagonal 1. So a matrix whose major diagonal equals to 1. So a matrix whose major diagonal equals to 1. Oh, nilikuwa nimemute without kujua. Sorry. We can continue. So I hope mnanisikia sasa. So tunasema when you have this kind of a matrix, so identity matrix, tuko tumeachia hapo. So identity matrix is a matrix whose major diagonal equal to 1. So a matrix whose major diagonal equal to 1. And two examples, we have two examples here. We have 3 by 3 matrix and 2 by 2 matrix. So our major diagonal 1 1 1 equals to 1. And also our 2 by 2 matrix 1 0 0 1, our diagonal matrix or our major diagonal equals to 1. So we call it identity matrix. So identity matrix is the matrix whose major diagonal equals to 1. Let's go talk about another one here, another type of matrix, number 7. Number 7, transposed. Transposed matrix. Transposed matrix. So transposed matrix is a matrix whose row and column has been interchanged. So refers to a matrix whose row and column has been interchanged. So a matrix whose row and column has been interchanged. Example, let's go do an example. So this one, if we have A, B, C, and D. So we transpose this matrix so that if we transpose our these items to become our column, and then this one, C and D, C and D in that order. Or if you have 3 by 3, A, B, C, D, E, F, G, H, I, we transpose. Now, if you were to transpose this one, then we start with the first one. We transpose the first one, A, B, C. Tukishamaliza ya kwanza twende ya pili, transpose ya pili, D, E, F. Tukimaliza ya pili, twende ya mwisho ya tatu, G, H, I. So that is how you transpose the matrix. So transposed matrix refers to a matrix whose row and column has been interchanged. Whose row and column has been interchanged. Na kama unatumia simu, make sure you don't auto-rotate your phone. Utumie in the normal way. Okay. The last one, let us talk about diagonal matrix. Diagonal matrix as our last type of matrices. Diagonal matrix. So diagonal matrix. So number 8. Diagonal matrix. Sijui kama inaonekana. Diagonal. So diagonal matrix, we have 2 types of diagonal matrix. We have major. So 2 types. So it is categorized into 2. We have major diagonal matrix, and then you have minor diagonal matrix. So major. So example IE. So we have our matrix here. We have A, B, C, and D. So this one represent major diagonal matrix. Diagonal matrix. Then you have another one here. This one represent minor diagonal matrix. Minor diagonal matrix. So that is all about. Diagonal matrix. And remember, diagonal matrix. We use this concept of diagonal matrix to determine the determinants. So we use this concept to determine determinants. So for example, how to find determinant? So determinant so we use the diagonal matrix to find determinant, and we can say so itakuwa ni A times D minus C times B. So that's how we find determinant. So you take the major diagonal with less minor diagonal, which in kusema this is the same as saying major. So determinant is equal to major. Determinant is like saying we take major diagonal with less minor diagonal. So major diagonal with less minor diagonal. Major diagonal with less minor diagonal. We continue. And we say, let us talk about operation of matrices. Operation of matrices. Number one, addition. Number two, subtraction. Number three, multiplication. And then number four, we have division. So the three of them. So addition, subtraction, multiplication, and division. Start with the first one, addition. So hopefully hapo ni clear. Okay, I hope hapo iko sawa. Okay, we can move on. So start with addition. We start with addition. So addition. Addition. And for addition, we just give an example. So this is our example. So we have this matrix 4, 3, 7, and 2. You're supposed to add it with 1, 0, 6, 3. So what will be the final if you add it? So now add hivi. So you take 4, you add with 1, itakuwa ni 4 plus 1, then 3 plus 0, then 7 plus 6, then 2 plus 3. So that our answer becomes 5, 3, 13, 5. That is all about addition. That is all about addition. So that's how you add when it comes to addition. Talk about subtraction. That one is number 1. Number 2, subtraction. So the same question, 7, 4, 7, 3, 2, less 1, 0, 6, 3. So that itakuwa ni 4 minus 1, 3 minus 0, 7 minus 6, 2 minus 3. So that our final answer becomes 3, 3, 1 minus 1. That one becomes our final. Our final answer. That is all about subtraction. That is all about subtraction. Then we can go to multiplication. Tufanya maswali zingine baadaye. So multiplication. And we give an example. So you multiply 4, 2, 3, 1 with 4, 3, 2, 1. 4, 3, 2, 1. So what will be our answer to that one? So our answer will be equal to, so you start with 4 times 4. So now then 4, you multiply by 4. Then 2, you multiply by 2. Then 2, you multiply by 2. So this one, 4 times 4 plus 2 times 2. So you need the first value. So unaenda ukiteremka hivyo. 4 times 4, and then 2 by 2. And then ukienda kwa ya pili, if you want to find the second one, the second itakuwa ni 4 times 3. 4 times 3, then itakuwa ni 4 times 3, then plus 2 times 1. So ndio tupate ya pili. So 4 times 3 plus 2 times 1. 4 times 3 times 2 times 1. Hiyo tumemaliza hivyo. Then tunaenda ya chini. Za chini mbili. So ya chini tunaanza na 3, you multiply by 4. So 3 times 4 plus 1 times 2. So 3 times 4 plus 1 times 2. And then pia unarudia the same to the other part. So 3. So hapa 3 times 3. So 3 times 3 plus 1 times. So 1 times 1. So 1 times 1. I hope hadi hapo tuko sawa sote. I hope mpaka hapo tuko sawa wote. So that's how you do it. Now we can find our final matrix. So 4 times 4 is 16. 2 times 2 is 4. So 16 plus 4, 20. Then 4 times 3 is 12. 2 times 1 is 2. So 12 plus 2, which is 14. And then 4 times 3, apa? 4 times 3 is 12. 2 times 1 is 2. So that will be equal to 14 also. And then we show 3 times 3 is 9. 1 times 1 is 1. So 9 plus 1, 10. So that is all about multiplication. So that is how you find multiplication of a number. So that's how you find multiplication of a number. That's how you find multiplication of a number. So let us go to the last one. Division, which we call it inverse. So division, which is also inverse. So another name is inverse matrix. So division, which is inverse. So division, which is inverse. So let us do it. Okay, let us do that one. Now for division, okay, before we do that one, let us set an NB. Yeah. NB, you can see. So a matrix can be multiplied by a matrix can only be multiplied. A matrix can only be multiplied if the number of column, in the first matrix, are equal the number of rows are equal to the number of rows of the second matrix of the second matrix. So a matrix can only be multiplied if the number of column in the first matrix are equal to the number of row in the next are equal to the number of row of the second matrix. So if they are not equal, then we cannot multiply the two. If they're not equal, then we cannot multiply the two. Let's go to division. Number 4. Division of matrix stroke A to P inverse. So inverse. And we say the following steps are followed when getting inverse of 2 by 2 matrix. So the following steps are followed when getting inverse of 2 by 2 matrix. So the following steps, let us see the steps. So let us state the steps. Number one, compute the determinant. Number one, compute determinant. So compute the determinant. After that one, step two, reciprocate the determinant. Reciprocate the determinant. Then part C, interchange the major diagonal. Interchange the major diagonal. Interchange the major diagonal elements. So interchange the major diagonal elements, and then ya mwisho interchange the signs of minor diagonal elements. So interchange the signs. So interchange the signs of the minor diagonal element. So illustration, we can do an illustration. Illustration. So illustration, let us use this illustration. Illustration. Find the inverse of the following. Find the inverse matrix of find the inverse matrix of that one. So find the inverse matrix of that one. So step number one is to compute determinant. So compute the determinant. What is the determinant? Someone to compute for us and then to give us the answer. Nikirab one side. So someone to calculate for us the determinant.
6.
X.
6.
6. Okay. Get us competency, which is 6. So we start with the step number one. So determinant. And we say it is equals to A. So in our case, it will be equal to what? So we start with the major.
4 times 3.
4 times 3. Then we minus
3 times 2.
3 times 2, which is 12. Minus 6, which is
6.
6. So that's step number one. Step number two, we reciprocate the determinant. So reciprocate the determinant. It will be equal to what? 1 over 6. Silvio. So for us to reciprocate, you just put it 1 over 6 if it is a whole number. So come on, 5, 1 over 5. So come on, 3, 1 over 3. So we reciprocate. So for us to reciprocate, we put it in fraction. So it will be 6, 1 over 6. Step number 3, we interchange the major element. Step C, we interchange major elements. Diagonal, remember they are diagonal. Major diagonal elements. So tukuje kwa yetu hapa. So our major, we interchange our major. Our major is 4 and 3, so we interchange them. So 4 iko hapa, 3 iko hapa, so we interchange them so that ikuje 3. So 3 kuje huku interchange. So 3 kuje huku, 4 iende huku chini. And then step number D. Step number 2 tunaifanyia tu bado hapo. Interchange the signs. Number D. We interchange signs. We interchange. Hata niandike vizuri. Nisikae. Tumesema hii hapa tuweke hii hapa chini kidogo. So the interchange signs equal 3 and 4. And then we interchange the signs of the minor. Interchange sign of minor diagonal elements. So, 3 na 2. So 3 is positive. We interchange the sign to be negative. So itakuwa minus 3. Hapa ni positive 2. We interchange the signs. Kama ni positive ikuwe minus 2. And then we input our reciprocate determinant here. And this one is our inverse. And that one is our inverse. And that one is our inverse. Now, before we do the inverse for 3 by 3 matrix, let us do a question from our past paper. So before we do 3 by 3 matrix,
kuna kibanda, kuna mzee anauzanga mzee. Kumuuliza kama kuna sakas, unaona sukuma sakas.
Wewe wa sakas, sijui saka manini. Wow, mute. So I think we are Saka. I'm a mute. We continue. So I want us to try a question in our past paper. Let me take a look for a good question that we can try. We can try for last sitting. But now we solve the equation using matrix. We solve the equation using matrix plus sitting. Just open a sitting, we do it again. Tunairudia again. We solve it using matrix. So open the last sitting question. Ama we look for another question. Because that one we did it. So yeah, last sitting tulifanya ama tufungue ya let me see. Let me dictate a question here. So let me dictate a question. So you come mtasikia. I'm dictating. This is the question, and then we shall wanasema. This is the question for August 2009. This is a question for August 2009. Najua iko kwa past paper. That's why I want to dictate. Ama niandike tu chini. Then tuifanye. Niandike.
Dictate.
Which one will be easier?
Dictate.
Okay, that one is for August. 2009 question number 1A. So inasema hivi. So I'm dictating. Utensil Ltd deals in production of cups and bowls. Juu wanasemaje? BOWLL. That one in Abud. So Utensil Ltd deals in production of cups and bowls. Full stop. The production requires machine and labor inputs as follows. So Utensil Ltd deals with the production of cups and bowls. Full stop. The production requires machine and labor input as follows. Require machines and labor input as follows. So Utensil Ltd deals with the production of cups and bowls. The production requires the machine and labor hours as follows. So inaandika hapa chini. So we have cups. So this is the machines. So wanasema machine hours per unit. Machine hours per unit. So cup ni 4, bowls ni 2, labor hours per unit. Labor hours per unit tuko na 3 and 2. So inakaa hivyo. So 3 and 2. And then full stop. Another statement. The available machine hours and labor hours are 100,000 and 80,000 respectively. 100,000 and 80,000 respectively. The available machine hours and labor hours are 100,000 and 80,000 respectively. Full stop. So tunasema the available machine hours and labor hours are 100,000 and 80,000 respectively. Required using matrix algebra. Required using matrix algebraic method. Find the optimal number of cups and bowls. Using the matrix algebraic method. Find the optimal number of cups and bowls that utensil company should produce. So using matrix algebraic method, find the optimal number of cups and bowls that the utensil company should produce. Kama umepata? So we do it. So navuta. So that we can do the question.
Let me know.
So let us do the question. Sawa. Now, let cup BC. Let cup BC and bowls B equal B. Sawa. So now, how many cups, how many hours of machine do we need?
2 hours.
So for machine, so tuanze na machine. So for machine, so we have 4C. What about bowls? How many number of machines? 2. 2, but now it is 2B because bulk is B.
B.
So what is the total hours of machine? Pale chini 100.
100,000.
Then we go now to labor. So how many labors do we need? 3C plus
3C. 2C.
plus 2B equal to
80,000.
80,000. Yes. Now we solve that one using matrix method. We solve this one using matrix method. Now, so we have 4C plus 2B is equal to 100,000. 3C plus 2B is equal to 80,000. Now, this one we are solving using inverse method. Inverse matrix method. Inverse matrix method. So let us solve it. Now, for us to solve it, we need to know that first, before even we solve this equation, we need to know that I want to write something here. A times X is equals to B. And then ndaonyesha, when we take the inverse of A, we multiply with B with X. Sorry, we multiply with the A, then we multiply with X. So inverse of A, we multiply with A, then we multiply with X. We shall get the other side also A inverse and B. We multiply inverse with B. So this one, when you multiply this one, these two, it becomes identity matrix. Then you multiply with X. Then it will be equal to A inverse B. A inverse B. Now I want to show you now something. Let us do this hours. This question of ours. So our matrix itakuwa ni aje? Itakuwa ni 4, 2, 3, and 2. Naiona? Can you see it? So that way imetokana na 4, 2, 3, 2. Then we multiply by, so we C and B, C and B. Then our answer must be equal to kwanza tulianza na gani? 100,000 and 80,000 and 80,000. Now, what I want to tell you is this part represents A. This part represents X, our unknown. So remember our unknown, C and B is our unknown. And therefore, C and B is X. And then this one represents B. Hadi hapo mmenielewa?
Yes.
So let us solve the question now. We can try and solve now the question very well. So we start by first finding. So tulianzia hapo. Ndio hiyo tumeweka hapo. If you can see it here, ndio hii. So iko na A, X, B. Number 2, we need to find the inverse of A. So we find the inverse of A. So how do we find the inverse? We start with the determinant. Determinant, which is, so we find the determinant. 4 times 2. 4 times 2 minus 3 times
2.
3 times 2, which is how much? Itakuwa ngapi hiyo?
2.
Itakuwa 2.
Yeah.
2, and then remember we find the reciprocate, which itakuwa ni
1/2.
Remember? Half hiyo iko sawa.
Yes.
Then the next thing, we interchange the major diagonal let us interchange the major diagonal. So tuanze major diagonal ni hii. So we interchange. So itakuwa 4 2 itakuwa 2
2
4.
4.
Hivyo.
Mhm.
Tunaanza na 2 4. Then our minor diagonal we interchange the signs. So zote ni positive zitakuwa negative 4. Kama hapa ni positive 3 hapa itakuwa ni minus 3 na kama hapa ni 2 itakuwa minus 2. Then we put our mwana back hapo. Now let us multiply hii tukuje sasa kwa hii. So hii tumeshafanya tukuje kwa hii. So we start with the inverse. Let us start with the inverse. 1 over 2. This one is our inverse, minus 2, minus 2, minus 3, 4. We multiply with our A. Our A ni original one. Our original one, 4, 2, 3, 2. Our original one is 4, 2, 3, 2. Then we multiply by our X. Our X ni unknown value, C and B. C and B. C and B must be equal to what? Now must be equal to our inverse. So tunachukua our inverse 1 over 2. So tunasema tunachukua our inverse ndio hapa. This one must be equal to our inverse, which is 2 minus 2 minus 3 4. Then we multiply with our B. Our B is the value provided, which is 100. Nimeenda sana nje. Let me put it that way. Hapo inaonekana 100,000 and 80,000. I think hapo iko sawa. Si iko sawa? Now, na tukasema tuende kwa ya tatu hapa. Let's go to the third one. The third one. Wacha niwarudishe hivi kidogo ndio niwaoneshe the third one. So the third one ndio huyu hapa. Sio kama inaonekana? The third one ndio huyu. Unamwona? Anaonekana? The third one. Someone? The third one mnamwona kweli? Hiyo identity matrix times X is equal to A inverse B. Inaonekana?
Yes.
Yeah. So tukitimes hawa wote kutoka hapa mpaka hapa. Tunapatanga identity matrix which is 1 0 0 1. So you try on your own time. You shall get what we call the identity matrix. Then CB. Then must be equal to the other side 1 over 2. 2 minus 2 minus 3 4, which is equals to 100,000 and 80,000. Now we can try and multiply. So huyu tukimultiply, so ukichukua 1 times C ni C, 0 times B ni 0, kumaanisha hapa at the end of the day ukiminus kila kitu hapa utabaki na C and B. So when you take the identity matrix to multiply with any value, you shall get the value yenye iko hapa. So ukichukua identity matrix you times any value here, you shall get the value here. So ukichukua huyu minus times huyu unapata huyu direct. So that is all about identity. This one do data identity matrix I. So C and B. So tena huku kwingine 1 over 2. So tuanze. So itakuwa 2 times. So hii inaenda na huyo. So 2 times 100,000 plus then huyu na huyo minus 2 times 80,000. Hiyo ni wa kwanza. So au tuende wa pili. Wa pili itakuwa -3 times. Itakuwa ni -3 times 100,000 plus huyu 4 times 80,000. So 1/2 will be equal to, so ya kwanza itakuwa ngapi? 2 times 200
200,000.
itakuwa 40,000. Huyu
40,000. Yes.
40,000. Na wa chini itakuwa 20. Sivyo? So tuanze na C. So C will be equal to a half and 40,000. And then B will be equal to a half times 20,000. So meaning this one is 20,000. C. And this one is 10,000 hours. So the number of hours required is 20,000 and 10,000. Iko sawa? Iko sawa? Hopefully iko sawa. Iko sawa? Okay, open May 2016. May 2016, question 1B. May 2016, question 1B. May 2016, question 1B.
Auntie, nani anaoga?
Yes. So open May 2016, question 1B.
Open heart surgery at 9 a.m. History. Which British monarch had the most lives? Henry. Okay, your turn. If you were punctured by an arrow in archery class, after removing the arrow, how would you treat what looks like an infection? So obviously, I'll go to the ER. You didn't let me finish. And you can't go to the ER. Well, trust me, you're saying this is over the season. Would John work? Yeah. History. William the bucket and had a bucket on his head. No, she get it out.
So kila mtu amefika hapo? That is on page, kufungua past paper yetu, that is on page 95. So I'm going to read the question. Anasema, a certain audit firm has two categories of employees. We have auditors and assistant auditors. So we have auditors. Auditors, we call them X. Then we have assistant auditors. We call them Y. So they have two type of employees. Assistant auditors. Apple. So auditors X, assistant auditors Y. And then we continue. The total monthly salary of one auditor. So one auditor, we say X plus 5 assistant auditor, which is 5Y is equal to what? 456, 456, 456, 755. And then we continue. Whereas the monthly salary of 3 auditors, 3X plus 9 assistant auditor, that one is 9Y, equals to 985, 985, 005, 005. The firm has a total of 6 auditors and 14 assistant auditor. Each employee contributes 12% of their monthly salaries toward a circle required. The monthly salary for an auditor in an assistant auditor using matrix algebra. So for now, we shall use inverse matrix. Tutatumia inverse matrix. So tutasema 1, 5, 3, 9. Then we have X, Y must be equal to 456, 755, 985, 005. So you remember the general formula of which is tutafanya tu hapa direct. So we did find the inverse determinant first. Determinant, which is 9 times 1 minus 5 times 3, which itakuwa ngapi? So itakuwa minus 6.
Yes, minus 6.
So minus 6. Then we find our reciprocate, which itakuwa 1 minus hivyo, sivyo? That form. Then you can find now our inverse. So itakuwa ngapi? So itakuwa 9. So we change the major diagonal. 9 and 1. Then the other one we interchange the signs. So minus 3, minus 5, then 1 over minus 6. Then remember, if you multiply this one with the original one, 1, 5, 3, 9, then you multiply with our X there, then we shall get this for kind of a solution. Then you put it hapa. Then tumesema ni minus 6, which equals to 1 over minus 6. Ikaria hapo. So that in this case, itakuwa ni 1 over minus 6. Then our inverse, 9 minus 5 minus 3, 1. Then you multiply with 456 755, 985, 005. So this one will give you, so ukichukua hawa will give you identity matrix, which is 1 0 0 1 x y, and then you remember when you take identity matrix times our x, it shall be equal to the same. So 1 over minus 6. So 1 over minus 6. So let's multiply. So 9 times 456, 755 plus minus 5 times 985, 005. Hapo. Then ya chini minus 3 times 456, 755 plus 1 times 985, 005. So what will be our final answer? So when we take identity matrix, we multiply with our x, our answer becomes 1 xy. So 1 over minus 6. So ya kwanza ni ngapi? 9 times 456, 75 plus minus 5 over that. Inakuja ngapi? Haraka haraka. Tukisonga. So mwenye amepata? Na kama ionekani museme ionekani. How much? Hakuna amepata? Itabidi nimefanya mwenyewe. 9 times 456, 755 plus minus 5 times 985, 005. So I hope it's correct. Minus 814 to 30. Alafu kuna minus 3 times 456, 755 plus 985, 005, which is minus 385 to 60. Now we can find the value of x and y. We find it here. So we find it here. So x will be equal to minus 1 over 6 times ya kwanza minus 814 to that. So what is the value of x? So one auditor is paid Kenya shillings 135 705. So one auditor is paid Kenya shillings 135,705. Let's say assistant. So how much is assistant being paid? Assistant auditor.
We can't see the screen, Mwalimu.
Yes.
We can't see the screen.
Okay. What about now?
It's okay.
Sawa. Okay, I was saying let me see. Let us see how to go about it. Kama inaonekana? Hapo? I hope hapo iko sawa. Now let us move on. So you are calculating the number of the amount of salary paid to the auditors. Sawa sawa, tulikuwa tumefika hapo. So let us compute. So tunasema kwa tumefika hapa. So for us to get x, if you go to 1 minus 6 times, so for x we multiply with minus 8, 14 to 30. Then we're going to get y minus 1 over 6 times minus 385 to 60. So how much is auditor being paid? So the assistant auditor is paid. The auditor is being paid 135,705. So Kenya shillings. So one auditor is paid Kenya shillings 135,705. What about junior? So the junior auditor is paid 64,000 Kenya shillings. 64,210 per month. So the assistant auditors are paid 64,210, while the main auditors are paid 64,210. Okay. Let's go to the part next. The requirement for part next. So we are required to calculate what to ambia. Let's go back to the question. Required the monthly salary an auditor and assistant auditor using Matrices. So an auditor is paid 135,705 and the assistant is paid 64,210. Number B, the total employee monthly contribution towards the circle. Now they say that they contribute 12% of their income. So for X, so one person contributes 12%. So times their income, which is 135,705. But how many are there in that company? They were around. So the firm has a total of 6 auditors. So 6. So that's their contribution. Then we have junior auditors also contribute the same amount, 12% of their income, which is 64,210. So how much are there? So junior auditors are 14. So the amount which goes to deduction, to SACCO, I mean, is that amount. So how much is that? 97? So it's 97, 707.6, and the other one 64 to 10 point. 64 to 10. 64 to 10. 64 to 10. Then the total will be equal to what? 205. So 205. So total amount being contributed 205. 580. Hey, hapa nimeandika vibaya. This one is, sorry, 107 872 872.8. So that is all. So that's all about that question. That is all about that question. So I think we can start from there, and then we shall start from where? We shall start from 3x3 matrix on Monday, so that tomorrow we shall have a con. Hadi hapo iko sawa?
Yes, okay.
It's okay. Let me give you some question. We shall go and check. So mtaniambia which one tutafanya. So we have these questions. Acha niweke hapa. So from our past paper, this is all about it. So I think there is no any other question concerning matrix apart from this one in inaeleka. So we have April 2022, question number 7C. We have November 2019, question number 1C. We have 4B and C. We have May 2019. Question number 20. We shall continue with some other question. May 2019, question number 4B. Well, then we have November 2018, question number 2B. Then you have May 2018, question number 1C. Make sure this question you try them. The different question have different settings. December 2017, question 1D. Then you have May 2016 question. So May 2016 question 1D. I think in a B here. We have November 2015. November 2015. Question number 1A. We also have September 2015. Question 1B. Then you have May 2015. May 2015. This is all. Question 2B. So angalia wenye ni ngumu, then we shall do in the next class. So angalia kwa hizo wenye ni ngumu, then we shall do in the next class as we introduce other subjects. Okay, that marks the end of our class.